Welcome to this little lab. This is the resonant length for sound tube, and this is the resonant length here. Okay, we're trying to find the speed of sound, and this is going to be a very interesting situation here, but there weren't really many good ones on the internet. So hey, I found this cup. It's actually a tennis ball holder, and we have some water in the bottom, and we have our trusty microphone, which we might have to put off to the side because this might get pretty loud. So here's my actual lab data. Did that all by myself. Yeah, lots of data. And we'll show you that later. So here's what happens. We have this tone generator, right? I found this online. Pretty easy app. You can find them online without buying the app. But I'm going to generate a tone at 473. Nope, this one's 515 hertz. Here's what it sounds like. Okay, I don't know how loud that is, so I might have to move the microphone. But that's 515 hertz, so that's what it sounds like. That's kind of what it looks like. And I'm going to put the sound right here. Now I moved the microphone, but I'm going to put the sound right there in the top. And then I'm going to add water, so this water column is going to go up. And hopefully you'll hear that there's a difference. And here's the concept. The waves are going to vibrate down, okay? Not like transverse waves, although we're going to draw them as transverse waves, but really they're compression waves. Yeah, like a slinky. And they bounce back. Okay, so what happens? On the way down and on the way back, if this length is just right, the waves that bounce back are going to reinforce the ones that are on the way down, and it's going to get louder. That's kind of what's going on with reinforcement. So that should happen at about 13.5 centimeters. So we measure this out at 13.5, okay, right there. Yeah, something like that guy right there. Now I don't have a tape. We could mark it. We could try that if we wanted to, right? Let's do that. Let's see if we can get close. So we're aiming for about 13.5, and I want you to be able to hear it. So hopefully you can see that mark. If not, I can see it. So we're aiming for that guy right there. All right, so what happens? We're going to take the sound here. We're going to generate the sound out of the bottom of the player. And hopefully guys, I think that's pretty convincing. Yeah, I heard it. I heard it get louder now. It didn't happen at 13.5, or did it? Maybe we marked it wrong. Maybe we have to get a little closer here. Well, that looks like 14.5. So maybe we have to go back and check our data. So I can write 14.5. That's not a problem. So here's what we're going to do. Now we're going to make the frequency a little bit, we can make it higher, right? And that means we're going to need a shorter column here. Or we could make a lower sound, and then we'd need a longer wavelength here. So let's see what we have. I can make one up. If we go to 557, okay, we could go to 600. Let's see what, yeah, let's go with 557. I haven't done that one before. Okay, I'll take a risk. Here's 557. Yeah, that's pretty convincing. Stop. Okay, so let's measure that. Let's see what we get here. And we can record, oops, we can record this on the data sheet. So I have 12.6. We have 12.6, and that was for what? 557. So 557, 12.6. Let's just keep doing that. Let's go to a higher frequency here. 600 is kind of obnoxious, but 6, not easy to get to, especially when it doesn't respond to your touch. 606, 606. Let's see what happens here. We play. that's pretty convincing. Now, what do we have? We have 11.2 at 606. So let's take one more, just to make sure that we're doing this right. Let's take this water. Let's pour all of that back into here. Okay. And let's get lower frequency. Let's see if we can do that. Now, I had 15 point for 473. We're supposed to be down to 15.1, so that's close. But I have too much water in here, so let's get a little higher than 473. We're going to go with 480 or something that'll let me get to. Okay, 497. 490. Not an obnoxious sound. Let's go with 490. Hopefully you can hear it. I'm pouring it so we don't trickle the water, but just pour a steady stream. Okay, if that doesn't convince you, nothing will. Okay. So we have this sound column here, and that says 14.2 centimeters. Okay, so I'm going to record all of that. What did we say that was? Let's make sure. At 490, we had 14.2 centimeters. Okay, so we will look at this as lab data, and then we will process those numbers later on. But again, this is a resonance column, and compressional waves going like this, like a slinky, bounce back, and there's a certain length where the wave going down and the wave going back can reinforce each other, and that loudness happens right here. Now we can also do this with an open tube, but it's a little harder to hear, so we'll talk about that later, but just to give you an idea of what resonance length looks like.